Here's problem 727. When an automobile moves with constant velocity, the power developed is used to overcome the frictional forces exerted by the air in the road. If the power developed in an engine is 50 horsepower, what total frictional force acts on the car at 55 miles per hour, 24.6 meters per second? 1 horsepower equals 746 watts, or joules per second. Alright, so we consider a car moving along, and there's a forward force of the engine, and this car is moving at constant velocity, which means that the frictional force acting on it must be equal to the forward force acting on it to give it a constant velocity. So right away we know that the frictional force is equal in magnitude to this forward force of the engine, because we have constant velocity. The value of that constant velocity is 24.6 meters per second, and we know that power should be equal to this forward force dotted with the forward velocity. So the power is going to equal force times velocity cosine 0 degrees in this case. Cosine of 0 is going to be 1. So it's simply going to be equal to this forward force times the velocity. Well, the forward force then would be equal to the power divided by the velocity. And we have the power, which is 50 horsepower, which we need to convert to watts. So we have 746 watts per horsepower. So that will give us watts, joules per second, divided by the velocity, which is 24.6. Everything's SI units, so we're going to get a force in newtons, which is 1516.3 newtons. That is the forward driving force of the engine, but we know that the frictional force is equal to that because we have constant velocity. So the frictional force is also 1516.3 newtons in the opposite direction, and hence that is the total frictional force acting on this car by the air in the road as it moves forward, 1516 newtons.